In the previous topic, we discussed the basic formula of law of sine. And we also discussed how to apply the law of sine in solving problems. So this time, let us now discuss law of sine, the ambiguous case. The ambiguous case is used to determine if a certain given or values can form a certain triangle. And if there is a triangle, what are the possible solutions for that particular triangle? Here is the summary of possible solutions of a triangle, given two sides and an angle opposite one of them. There are three cases that we will going to discuss here. In the first case, the given angle is an acute angle, and A is less than B. There are three possibilities. For every given, let us remember that capital A is the given angle, and opposite of capital A is small a, which is the side. So small a is always opposite the given angle. And then B, or small b, is the another side given. So in case 1, the given is always acute angle. So you should remember that. And remember also that the opposite side from the given angle is always smaller than the other given side. So here, side A is always smaller than the other side. So if you are given angle, an acute angle, and the side opposite to the acute angle is always smaller than the other side, there are three possibilities. In the first possibility, there are two solutions. So in order to verify that there are two solutions, we need to solve first for B sine A. Okay, so we need to solve for B sine A, wherein B is the another side given and A is the given angle. And then we will compare it to the other side. If the side opposite to the given angle is greater than the value of B sine A, then there are two possible solutions. So in the illustration, either you can form acute triangle or obtuse triangle. And then if you have two solutions or two possible solutions, we need to show those two triangles. So meaning, if you have two solutions, you have two possible triangles. One is an acute triangle, and the other one is an obtuse triangle. Another solution is we have one solution. In this case, the value of B sine A is equal to the opposite side from the given angle. So in that case, we only have one triangle that we can form. And lastly, there is no solution. That will happen if the side opposite from the given angle is smaller than the value of B sine A, meaning we cannot form any triangle. So in that case, we will not solve anything. We will just state that there is no solution by showing that the given side from the opposite angle is smaller than B sine A. So in case 1, always remember that the given is acute angle and the side opposite from the given angle is smaller than B. So in case 1, we will always solve for B sine A. Okay, we will always solve for B sine A. And then we will compare it to the side opposite from the given angle. And then after that, we can now determine what will be the solution or how many solutions that we have. Either we have two solutions, we have one solution, or we have no solution. That is for case 1. In case 2, the given is still acute angle. But this time, the side opposite to the given angle is greater than or equal to B for the other side. Remember, in case 1, the side opposite from the given angle is smaller than or less than the other side. In case 2, it will become greater than or equal to B. In that case, whenever that the given side is always greater than to the other side or equal to the other side, we have an exactly one solution, meaning we have only one triangle. So in case 2, no need to solve for B sine A. We only solve for B sine A if we are in case 1. So the first thing that we will do here is to identify the case given, whether it is case 1 or whether it is case 2. Therefore, in case 2, we only have one solution. And since we have one solution, we need to solve for the dimensions of the triangle that we have here. In case 3, this time, the given angle is either obtuse or right. Unlike with case 1 and 2, case 1 and 2, we are both dealing with acute angle. In case 3, we now have obtuse or right angle. In that case, we have two possibilities. There is no solution if the side opposite from the given angle is less than or equal to the other side, meaning we cannot form any triangle. But if the side opposite from the given angle is greater than the other side, then we have one solution, or we can form a triangle. So there are only three cases here. Remember, case 1 is an acute angle. Case 2 is also an acute angle. Case 3 is about obtuse or right triangle. In case 1, the side opposite from the given angle is less than the other side. In case 2, the side opposite from the given angle is greater than or equal to the other side. So please take note of their differences. The first thing that we will do here is to identify what case. After identifying the case, we will now identify the number of solutions. After we identify the number of solutions, we will solve for the dimensions of the triangle. Okay, so let us answer these examples. Let's start with number 1, letter A. How many solutions are there in each case? In this given, we will just identify the number of solution for a particular given. So here, the given value of an angle is 47 degree. And then C is 20, side C is 20, and side A is 12. In this given, the given angle is angle C, which is 47. So automatically, opposite side of angle C is side C, which is 20. So in this given, the given angle is acute because that is 47 degrees. And then the opposite side, which is C, when we compare it to the other side, which is A, C is greater than A because side C is 20 and side A is 12. So this is 20 greater than 12. Okay? So from the given three cases earlier, we can identify that the given belongs to case number 2. And in case number 2, once we already identified that that is already in case number 2, we can say that there is only one solution. That's it. We are only asked to determine the number of solutions in this given. Again, the given angle is acute because that is 47. And then opposite the side C is angle C, and side C is 20. And that is greater than to another side, which is A, which is 12. Therefore, it belongs to case 2. And our conclusion, there is only one solution. So that is how we use the given cases earlier. Now let's proceed. This time, let us answer number 1, letter C. So from the given, we are given angle A, which is 114 degrees. Therefore, the given angle is obtuse. And opposite of angle A, we have side A, which is 21, and side B, which is 32. So comparing the sides, we can say that side A is less than 32. Now, since the given angle is obtuse, we can already say that this belongs to case 3. Remember, for case 3, the given angle is obtuse or right. Here, the given is obtuse, therefore it belongs already to case 3. Now, we will just compare the sides given. A is 21, that is less than with B, which is 32. Wherein A is the opposite side from the given angle. Since the opposite side from the given angle, which is A, less than another side, which is B, therefore, we can already conclude that there is no solution. Because A is less than B. If A is greater than B, then we have one solution. But remember, it belongs to case 3 because that is obtuse. Now let's have letter D. In letter D, the given angle A is 67 degrees. So the given angle is acute. And then opposite angle A is side A, that is 18. And another side is B, which is 20. Comparing them, A is less than B. So using these values, we can say that this belongs to case 1. Now, since we are dealing with case 1, we need to solve for B sine A. Remember, we only solve for B sine A when we are in case 1. So solving for B sine A, that will be B, which is 20, sine 67 degrees. So when we solve for that, that is equivalent to 18.41. Comparing B sine A and A is 18 and B sine A is 18.41. Therefore, we can say that A is less than B sine A. Okay, because again, A is 18, and then B sine A is 18.41. Therefore, from that particular given, or that from that particular values, we can say that A is less than B sine A. And then after you solve for B sine A and compare it with other side, which is A, let us now determine the number of solutions that we have. Remember, we have three possibilities. Either we have two solutions, either we have one solution, or either we have no solution. Okay, so we can go back to the cases that we have earlier. So going back to the cases earlier, since A is less than B sine A, therefore, we can say that there is no solution. Because A is less than B sine A. Therefore, there is no solution. If A is greater than B sine A, there is, or there are two solutions. If A is equal to B sine A, there is one solution. But since here A is less than B sine A, there is no solution. Now let us continue answering the examples. This time we are asked to solve the triangle ABC, where A is equal to 9.1, B is 12, and angle A is 35. So since we are asked to solve for the triangle, meaning we need to give all the dimensions of the triangle. It means we need to give all the sides and the angles, all the missing sides and all the missing angles. But before that, we need to determine the number of solutions that we have for this kind of given. By looking at the given, we say that the given angle is acute because that is 35 degrees. And then opposite the given angle, which is A, we have side A, and that is 9.1. Comparing it to the other side, which is side B, that is 12. Therefore, side A is less than side B. By considering this given, we have acute angle. Opposite the given angle, which is side A, is less than B. Therefore, we are dealing with case 1. Again, the first thing that we will do is to identify which case does the given belong. Since we are in case 1, we need to solve for B sine A. Wherein B is 12, sine the given angle, which is 35 degrees. So before that, we have 6.88. When we compare it with A is 9.1. Therefore, we can say that A is greater than B sine A, which is 6.88. Since A is greater than B sine A, therefore, we can say that we have two solutions. It means that we can form two triangles because we have two solutions. Now, since we have two solutions, we need to show the dimensions of those two triangles. But the original given, which is 9.1, 12, and 35 degrees, will still remain. Now, let us show that two possible solutions or two triangles from the given here. Again, we have two solutions, so we need to show two triangles. Let's start showing the first triangle. So let's write here first solution. So solving for the triangle, let us assume that this is our triangle. This is A, B, and C. So this is 35 degrees. And then side A is 9.1 and side B is 12. So here, we can solve for the missing sides and angles. Using the law of sine, we can use angle A and side A, and then we can also use side B and angle B. So meaning we need to solve for angle B. So that will be sine 35 over its opposite side, which is 9.1, equals sine B, which is unknown, all over 12. When we simplify this, we'll have 9.1 sine B equals 12 sine 35. Since we want to solve for B, we can have sine B equals 12 sine 35 over 9.1. Okay, so to do that, we need to press shift sign in our calculator. So press shift sign on your calculator, and then you press 12 sine 35 over 9.1. So doing that, we can say that B is equivalent to 49.14 degrees. So that's angle B. So let me write it here. 49.14 degrees. So that's angle B. Now let us solve for the missing angle. We already have angle A, which is 35. We also have angle B, which is 49.14. We can now solve for angle C. Again, a triangle is always equivalent to 180. Therefore, angle C can be solved by adding 35 and 49.14, and we subtract the sum from 180. So basically, our solution will be 180 degrees minus 35 plus 49.14 degrees. Solving for angle C, we can say that angle C is 95.86 degrees. So those are the three angles. A is 35, B is 49.14, C is 95.86 degrees. From there, we can now solve for the missing side, the last missing side, which is side C. So remember that C is 95.86. So let me write it here. C is 95.86. To solve for side C, let us use the original given that we have, which is angle A and side A. In that case, we can have sine 35 over 9.1 equals sine 95.86 over side C. So simplifying this, we can say that C is equivalent to 9.1 sine 95.86 all over sine 35. So we are now solving for the length of side C. Solving for that value, we can say that side C is 15.78. So side C is 15.78. So in that case, we already solved for the first triangle. We already solved for all the remaining angles and sides. Now this time, let us use the same given and let us show the second triangle. Remember earlier, we found out that there are two solutions. So we need to show the two triangles. Okay, so let me retain the triangle there. And now we will solve for the second triangle. Remember, in the first triangle, the first thing that we solve is angle B. And angle B is 49.14. In order to solve for the second triangle, we will now use that value, which is 49.14 for B. So in the first solution, angle B is acute angle. In the second solution, angle B will become obtuse. To do that, you will just subtract 49.14 from 180. So 180 we will now solve for the new value of B. That will be 180 minus the previous value of B, which is 49.14. Therefore, the new value of B will be 130.86. So this time, in the second triangle, angle B will become obtuse, and its new value is 130.86. In the previous value, that is 49.14. But since we are now dealing with the second triangle, it will now become 130.86. But still, A is still 35, side A is still 9.1, and side B is still 12. Now, since we already have two angles, A and B, we can solve for C, angle C. Again, to solve for angle C, that is just 180 minus 35 plus 130.86. So that the new value of C now is 14.14 degrees. So angle A is 35, angle B is 130.86, and angle C is 14.14. Now we need to solve for the last side, which is side C, using the values that we have here. So it's still more convenient if we will use the original value given, which is angle A and side A. And then let's solve for side C. So to do that, we have sine 35 over 9.1 equals sine 14.14 over side C. Therefore, C is equivalent to 9.1 sine 14.14 all over sine 35. Therefore, the length of side C is 3.88. And that is now the dimensions of the second triangle. Again, since earlier we found out that there are two solutions, we need to show the dimensions of two triangles. If we found out that there is only one solution, we only need to show one triangle, because it's not possible to have another triangle because we have only one solution. If there is no solution, there is no need to solve for the dimension because there is no triangle that we can form. Always remember that. And that is how we solve this particular number 2. Now let's have our last example. This time we are asked again to solve triangle ABC, wherein side A is 25, side B is 46, and A is 37, which is acute. So from the given angle is acute. And then opposite the given angle is A, side A, which is less than to the other side, which is B. So from these considerations, we can say that we have case 1 again, or the given belongs to case 1. So since we are in case 1, we need to solve for B sine A. B sine A is the length of the other side multiplied to sine of the given angle. So that will be 46 sine 37. And that is 27.68. When we compare B sine A, which is 27.68, to the side opposite the given angle, which is A, we can say that A is less than B sine A, because A is only 25 and B sine A is 27.68. From here, we can already say that there is no solution. There is no solution because the side opposite from the given angle, which is A, is less than B sine A. Therefore, there is no solution. Since there is no solution, we don't need to solve for any triangle because with this given, we cannot form any triangle. That is why there is no solution. Okay, so we will already stop here. There is no need to solve for the dimensions of the triangle because we found out that there is no solution. We will only show the dimensions of the triangle if you have one solution. You need to show the dimension of one triangle, or if you have two solutions. And you need to show the dimensions of those two triangles. But again, in this example, we don't have a solution, or we found out that there is no solution. Therefore, there is no triangle and there is no dimension that we need to solve. And that is how we use the law of Sine for ambiguous case. Again, the ambiguous case is used to find the number of solutions for any given values of sides and angle. And it is also used to determine the number of triangles that we can form from that particular given. Next meeting, we will going to discuss law of cosine.